Synthetic division is awesome for the mere fact that it's easy, and as soon as you pick it up once, you usually don't screw it up. But here's the most important part. So you might want to highlight this, write it down in your notes, or it's already there. But it says synthetic division is a shortcut to dividing polynomials by binomials of this form. It can only be used for binomials. You cannot use it when you're a divisor. So your divisor must be a binomial with a leading coefficient of 1, like x plus 3, x minus 9. If you are dividing by a monomial, which we don't really do much, it's more Algebra 1, not going to work. In your Charlie Brown puzzle, one of the divisors was x squared plus x minus 1. Nope, you're still going to have to use long division because it's not a trinomial. Now the tricky part for some students is that it's always in the form of x minus k. So what happens is they tend to struggle a little bit with what's going on, okay? Now this first one, if you want to like write over the numbers, that's fine, but really what I'm going to do is I'm going to show you how this division works, okay? Notice, the other bullet up here before I move forward, it says there must be a coefficient for every possible power of the variable. And if you're going, what does that mean? Well, do you remember when we did long division, even in the Charlie Brown, like color by number, let's say that I asked you to do x squared plus 9 divided by x minus 3. Okay, totally just making this up. What's your divisor, everyone, in this problem? X minus 3, so that went on the outside, right? And what did we write on the inside? Did we write x squared plus 9? What did we write? X squared plus 0x plus 9. We needed a placeholder. And so right now, underneath our coefficient, x squared, the coefficient on x squared is 1. We needed a 0x. The coefficient on 0x is 0. 9 is not a coefficient, y'all, that's a constant, okay? So the same thing applies to where you have to have placeholders. So if your highest exponent is a 5, then you need a spot for the exponent of 5, 4, 3, 2, 1. Your constant always goes at the end, okay? So that is not going to change. Now, once again, this problem that we're looking at here, this is x to the 4th minus 10x squared. I won't read it. But this is a polynomial of 4 terms. We're dividing that by a binomial leading coefficient of 1. Whoop! Okay? So it's linear. So if you notice, these binomials are always going to be linear. It's not x squared. That won't work. So it has to be a linear binomial. Do you know what linear means? Degree 1 with a leading coefficient of 1. Now, here's what you do. You're going to see me do this, but I'm going to highlight this. You're going to see me draw this funky little like L-shaped. It's like an exaggerated L. So I'm going to kind of go over, I'm going to exaggerate this. I'm going to go over this example with you, and then we'll do one on our own, and I'll have you try. So these are not tremendously long notes. So what happens is let's take a look at what is she doing here, right? So what happens is inside this, where it says divisor, I have a 1, a 0, a negative 10, negative 2, and 4. And I'm hoping you realize, where did those come from? Anybody know where those come from? Where did I get those? And they're what of this? They are the coefficients. What's in front of the x to the 4th? 1. What's in front of, oh no, what's missing in between a power of 4 and a power of 2? So that's why I put a 0. We have 0x to the 3rd. Then negative 10, negative 2, and 4. So what's cool about this is I don't even have any variables. Okay? Now notice the divisor says x plus 3. This throws people for a loop. They're like, Mrs. Green, why isn't there a 3 there? Well, remember, up here in our notes, it's always in the form of x minus k, where k is a constant. So if I write down x minus k, notice that this is the opposite of what it says. Okay? So it's almost like I could do x minus plus a negative k, right? So here, it should be negative 3. So it's always the opposite of what you think. So if you see minus 3, that's fine, it goes in as a 3. So the k always goes out here, okay? Now, here's how you do synthetic. Once again, I'm going to write over this so you can kind of see what I'm doing, okay? Here I go. The way that you do synthetic division is it's really much long division, except for you don't have to worry about, like, what does it go into with variables with it. So we take out the problem that makes people like, okay? So watch what you do. You always bring down first. So that's why there's an arrow. You bring down the 1, okay? You multiply. We've done the same stuff. What's 1 times negative 3? Negative 3. So I write it here. Now we add straight down. 0 plus negative 3 is negative 3. You do it again. Negative 3 times negative 3 is 9. I add straight down and get negative 1. Negative 1 times negative 3 is 3. I add straight down. Multiply negative 3, and I'm 1. Do you see why I stopped? There's nowhere else. Now this is where people get a little confused. This last number is always your remainder. So what happens is I'm going to have a 1 over x plus 3 in my answer, because we always put the remainder over the divisor. Okay? Now, to write our final answer, students, look up here, because this is confusing to people. They're like, well, how do I know? This isn't your final answer. You have to write it like a polynomial. So if this is the remainder and you go backwards, a polynomial is always the constant, the linear term, the quadratic term, the cubic term, the power of 4 term. I could keep going backwards, right? So here's how I wrote my final answer. You ready? It said 1, so that correlates with 1x to the 3rd. These are coefficients. The next term would be quadratic. That correlated with minus 3x squared. Minus 1x plus 1 is your constant. And then see this remainder of 1 right here? It went over the divisor as normal. Now, in this first example, I won't always draw this bar for you. But first of all, let me ask you a question. Let's go ahead and set up our dividend. Now, look at it. Are there any placeholders missing? 3, 2, 1, constant. All right, so here we go. Let's write the coefficients. I'd space it out to give yourself some room. 2, negative 13, 26, and negative 24. So that was easy, right? Now, our divisor, remember, if you're going to use synthetic, it has to look like that, meaning it's linear, degree 1, leading coefficients 1, it's a binomial, so that works. What are we going to put out here? What is the k in x minus k? 4. Good. So if you do x minus k, like above it, to kind of remind yourself, the k is 4, not negative 4, okay? So here we go. The first part, remember, is to bring down. If you remember to bring down this leading coefficient, you're good. Okay, here we go. Let's multiply. What's 2 times 4? 8. You got to put it under this one. It's kind of like long division when we kept ourselves lined up. Now add, what's negative 3 plus 8? Negative 5. Now we do it again. Let's multiply. Negative 5 times 4 is? Negative 20. What's 26 minus 20? Or at plus negative, right? 6. 6 times 4 is? 24. Ooh, what's negative 24 plus 24? Y'all, this last number is always our remainder. So we don't have to worry about a remainder. Now, if you're going, well, what's our final answer? You have got to write it back correctly. So you're going to write no remainder, right? What's this going to be? The constant. So the way that you work backwards is you work backwards in a polynomial. You have the constant at the end, then you have the linear term, then you have the quadratic term. So your answer would be 2x to the second minus 5x plus 6. Edwin asked a great question. He just said, where did this go? What are we doing? We're dividing. When you divide things, don't things get smaller typically? Not always, right? So watch. Edwin, you need to understand that if you are asked to divide this, and I'm going to write this up here. If I look up, even though we know our answer, I'm going to just rewrite this. Our final answer, our quotient, was 2x squared minus 5x plus 11, right? Do you all know how to check your answer? Right now, I want everybody to do this. I want everyone off to the side right now to write check. Do this now, because I'm glad he brought this up. Write check. We check an answer to division. So look up here. I'm going to make it real easy on you. Ready? Watch this. What's 6 divided by 2? Now, you know how you can check it? You go backwards. So we just divided, so use multiplication. So let's multiply. What's 3 times 2? 6. So what we're going to do to check this is we're going to multiply this times this. So I want you all to write this down now. You ready? 2x squared minus 5x plus 11 times x minus 4. Now, you might be going, I don't want to do this. But you know what? This is great practice for your quiz next week. So here we go. If we do not get, Edwin, where we started, then we have a problem, and that means you divided wrong. Y'all can always do this. Ready? Here we go. 2x to the second times x is 2x to the third. 2x times negative 4 is minus 8x squared. Oh, did I write the wrong thing down? Why did I do that? Thank you, everyone. You're on the ball. Yeah, that would have been a disaster, wouldn't it? Sorry. Now let's multiply our answer back by the divisor to get the dividend where we started. So we have, okay, so I just distributed through the first term of the trinomial of our answer. Now, negative 5x times x is minus 5x squared. Negative 5x times negative 4 is plus 20x. If I make another mistake, let me know, because I'm trying to multitask here. Now, the last term of the trinomial, 6 times x is 6x, and 6 times negative 4 is negative 24. Now, combine like terms, everyone. Put it in order, standard form, make it look pretty. So we have one term, so there's 2x to the third. Whoop, there it is. Let's see, a minus 8 and a minus 5, x to the second. Well, that's minus 13, x. Whoop, there it is. It's like I'm singing that song. 20x plus 6x is plus 26x, and then minus 24. So did we get back to where we started? So that means this right here in red, that means that's our answer to this division problem, and we did it correctly. Okay? Is everybody good? Awesome. Okay.